Okay, the last episode of the spatial diagramming exercise was using um, spatial summary of Connors, but I'm going to work with Nick Heyman's draft of, and let's go back to a couple of documents that I've asked you all to complete. So I'm going to share Nick's responses to the survey, right? In a single sentence, a homeless shelter, disadvantaged youths for particular, I'm generalizing, right? 8,000 square feet, not including residential use occupancy, 8,000 square feet. We have that accounted for in your spatial summary, but it's not including residential, which we're going to have to do, and we'll have to guesstimate that, right? At 200 square feet gross per person. So that's going to add another 8,000 square feet to your program. Again, this is uh, agnostic. This is a spatial summary agnostic of whether or not it's correct. So we're looking at Nick's summary here, and we need to add this line item 8,000 square feet for residences. Remember, these are rules of thumb, right? They work in the aggregate, but when you get down to smaller numbers, it may or may not be uh, appropriate. But okay, so we have 7,100 square feet, 8,000 square feet. We also need to account for circulation, which we haven't done here, as Connor did in his. So let's do a quick calculation. 7,168 plus 8,000. That's 15,168. Let's multiply that by 20%. So we need another 3,000 square feet for circulation. All right. You guys are adults, so you can follow along with what I'm doing here. I'm going to go through the same summary that I did with the first project. So residential occupancy, we're going to say 8,000 square feet. All right. Let's look at this and see what we can group together, because we're not, at this point, we really can't. First of all, floor one and floor two, we don't really care about how we're dividing that up quite yet. We're just trying to account for all the space. So I'm going to deal with all this as if we needed, okay, here's what we need to program. Restrooms, there are some things I'm going to group together, right? Maintenance, let's call this common area. I'm just going to say C, maintenance, common area. All right, cafes, resources, common area, private pods. I'm not sure what that is, but that's a small number. But let's say that this is non-residential. So we've got a bunch of stuff: dining space and kitchen. So commercial kitchens. This is going to be a separate line item. I'm going to take dining and cafe and group them together and just call it dining. That's going to be some kind of assembly use. So it's 400 plus 1300 is 1700. Let's just see that we've accounted for that. Studio, gym, relaxation. There's some public space and therapy. Let's call this assembly also. Again, we can go back and let's say A2 is going to be this, and that. So A2, let's add that up. 800, 400, 500, 600. Let's add the private pods as well. 468. I've done something wrong here because that number's way off. Okay. 800, 400, 500, 600, 468. We got 2768. So we've accounted for that, 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 and that under A2. Okay, let's call this A1. Common area. Let's get a number for that. 300 and 300 and 600. And the lobby. Yeah. Although that should go into circulation, but that's a small number. We can figure that out. 300 plus 400 plus 300 plus 600 2, 3, 4 is all going to be resources. Enter. Plus, that's about 1600. Right? So we have have we accounted for all this? 1700 plus 2768 plus 1600. That is 6068. What am I missing? 100 square feet is missing somewhere. Not a big deal. We'll just take off 100 square feet there. So I got 6068 square feet for this stuff. Doesn't matter floor 1 or floor 2. Two residential is 8,000 square feet, and then I've got 3,000 for circulation. We could refine this. Oh, I left out the kitchen. That's where the 1,000 square. And then kitchen is 1,100 square feet. Right there, that was the difference. That's where that number came from. I know this is somewhat sloppy, but that's cool. Kitchen, commercial kitchen, right? 1,100. Uh, assembly one, 1,700. Assembly two, 2,768. When you have numbers like this, you probably want to round them up or down. We can just call this 2,800. Assembly two, residential kitchen, assembly one, assembly two, common area, services, whatever. 1,600. And residential. Oh yeah, we have residential. All right, let's add this up and just see where we're at. We're gonna scratch that out. 8,000, 1,100, 1,700, 2,800, 1,600. Oh, and circulation, 3,000. We've got 18,200 square feet. So here's what we have from Nick Heyman and so forth. All right. I'm going to use the same square. The square is going to be 10 by, actually, let's make this a little more interesting. Let's make a square be 8 by 8. So each square is 64 square feet. So we're going to have to do a little bit of math here. But that means that 1 inch here, 1, 2, 3, 1 inch equals 32 square feet. Sorry, 1 inch equals 32 feet. 1 square inch is 32 times 32 is 1,000 square feet. 1,024 square feet. That's the entire thing there. Everybody follow that? I'm using, and the reason I'm doing this is that if we draw this in Illustrator and we use 1/8, 1 inch, 1 inch equals 32 feet. Sorry, that's not what I wanted to do. 1 inch I want to be 8 feet. What will we need for 80,000? So that means 1 inch is going to be 32 feet. Let's deal with that. If I use the 10 by each square to be 10 feet, that would be 100. Maybe, you know what? The heck with this. Let's go back to the same scheme that we use. 10 feet, 10 feet. 8,000 square feet residential is going to be. Let's start here. 8,000. We need 1, 2, 3, 4, 5, 6, 7, 8. That would be 800. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If this is 8 and this is 10, that means 80 feet by 10. Let's see if I've got that right. 80 times 10. No, sorry, that's 800. And 10 times that. I've done the other one correctly. 800 times it's out. 80 times 80 times 100. Yeah, sorry about that. Okay, so 80 times 100. That's 8,000 square feet, and there's our residential. So I'm approaching this a little bit differently than I did here. I'm sort of going to lay it out, splatter it out, however. So we've accounted for the 8,000 square feet of residential. Now we need the kitchen, 1,100. 1, 2, 3, 4, 5. That would be 50. 1,100 divided by 50. 22 that one. Three, 4, 5 is 500. And another, so there's 500 square feet. Another 500, that's 1,000. There's 1,100. Kitchen. All right, that's 1,100. Got that. Assembly 1, 1,700. 1, 2, 3, 4, 5, 6, 7. Eight. That would be 800. Two of these would be 1,600. There's 1,700. Assembly 1. That's my 1,700. Assembly 2, 2,800. What's 1,000? 1, 2, 3, 5, 6, 7, 8, 9, 10. That's 1,000. Two of those would be 2,000. And then we need 8. 1, 2, 3, 4, 5, 6, 7, 8. There's 2,800. A2, 2800. Common function 1600. Let's go 8 and 8. 1, 2, 3, 5, 6, 7, 8. So two of these would be, there's 1600. Common. Circulation 3000. Let's just do 3 times 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. That's circulation. 3000. Have we got everything? I think so. 8,000 plus 1,100 plus 1,700, 2,800, 1,600, circulation, 3,000. Let's add that up. 1,700, 1,100, 8,000, 2,800, 1,600, 3,000. 18,200. That's it. So that's what we got for Nick Heyman so far. 18,200 square feet. And each one of these sides is 10 feet. Nick wants to use 50 Staniford Street. So let's go to Revit and just kind of get a sense of what that floor plan. We're looking for a footprint for 50 Staniford Street, right? I'm going to share that Revit window, right? So now the Revit window is in here, and here's what I'm drawing on. So, all right, I created a linked model, but whatever. We're going to look at the floor plan. Let's look at the ground floor plan. Let's not get confused by all the clutter in here. But basically, what I wish to do is to define a rectangle, more or less, that represents the footprint of the building, right? I'm going to cheat a little bit here. I'm going to draw a region. Okay, region allows me to draw a shape and then fill it with something. So I'm drawing, you see what I'm doing? I'm basically approximating a rectangle. That rectangle is 251 feet. Let's write that down, right? We got 250 feet, and then we got 100 feet in that direction. Everybody see what I'm doing there? Remember, at this point, we're not trying to land somebody on the moon. We're trying to get in orders of magnitude. what it is that we're dealing with. So 250 by 100, if I finish all that, it's telling me what that shape is. There's 25,584 square feet for that shape. More importantly, I have dimensions for it. I have a long dimension of 250 feet and then a depth dimension of 100 feet. I can use that in this drawing. Let's go back to this drawing and say, how am I going to, this is Staniford Street. How am I going to represent this at this scale? Easy peasy. I don't know what happened with all this. I hope I'm still recording. I think I am. Okay. How am I going to represent all this at the scale that I'm drawing here? I need to draw 100 feet in this direction and 250 feet in this direction. So 100 feet this way is easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 250 in this direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 200. 1, 2, 3, 4, 5. There's 250. Staniford. 250 by 100. Nick, everybody, can you see how this is 25,000 square feet? Right? How does it fit here? I can take this shape and draw it on top of here. Or I can take these shapes and move it down here. Now I'm doing all this manually, but if I wanted to get a quick and dirty idea of what it would look like here, I would draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Goes there. So watch what I'm doing here, right? There's the depth of it. It's going to stop here, right? Because I've already counted that out. One, two, three, 4, 7, 8, 9, 10. There's Staniford. The footprint. Okay, space doesn't quite fit, but that now you can take that rectangle, multiply it over 2 floors. I want to keep this within a half hour. Have a good look at this. These drawings are saved, and we'll talk about it on Tuesday.